Good evening, all. Today, we are happy for the second series of the Industrial Talk, a gentle introduction to AI industrialization. And we are happy to present to you the resource person of the day, Dr. Ebenezar Isaac, AI Technical Product Manager, Global AI Accelerator from Ericsson. Welcome, Dr. Ebenezar. And today we are happy to have industrial person for the day for the talk on the topic, a gentle introduction to AI industrialization. Right? As you know, we are meeting with the students. This is a part of our internship program, and we have students from ASDNB College, like 131 students, right? They are from BSc and BCA students. They're undergoing 1 month internship training online with a hands-on session. As a part of it, during our internship program, we bring resource persons from industry to really know about how it has been applied onto it. And we are happy to have Dr. Ebenezar Isaac. After receiving his PhD from Chennai University, Eby completed his postdoctoral research in Robert Bosch Center for Data Science and AI, IIT Madras. He then joined the GAIA division of Ericsson as a data scientist and is now an AI technical product manager. His doctoral research was on video analytics, gate biometrics, and machine learning. His postdoctoral research includes telecom data storage optimization through AI-driven knowledge-based analytics and control and class imbalance learning. His research papers are published in reputed journal venues, including IEEE, Elsevier, and Springer. He has also filed multiple patents on anomaly detection. We're so happy to have you, Eby, here. Over to the resource person for the day.
Thank you for the kind introduction. May I begin by sharing my screen?
Yeah, please do.
Okay. Let me know once you're able to see the presentation content.
Yeah, we are able to see the presentation.
Okay. Great. Greetings and warm evening to all of you. And of course, you would all know what AI typically is. So AI in broad terms would be to mimic human-like behavior or any sort of intelligence in computers. And the branching of AI includes many other forms, machine learning, which has become synonymous with AI now, would make computers or systems learn from experience. So R&D, research and development in AI, is one thing, and industrialization and employment, that's IND, is another. So in R&D or in even your basic research in your undergraduate and your postgraduate studies, you would be taking up AI problem that is existing and that is an open problem, and you'd be doing a proof of concept, be taking a data set for that problem, running in some algorithms to give the desired output, and the output is better in accuracy or any other form of metric that you'd consider to compare the existing and the proposed. And if it's better, you publish it or you complete your report and you're done with that. But when you come for industrialization deployment, you'd have to think a lot of other things. You'd have to think from the user perspective and the business perspective. And we'll be covering a whole lot of that in the presentation in the future slides to come. And the target audience for this presentation would be people who are already comfortable with the basics of AI and ML. And even if you're not, that'd be still good. I'll try to cover much of the ground as possible so that you will not be left in the dark. So every time it comes to the jargon that person with AI and ML familiar with, I'll try to expand it to the best of my knowledge. So moving on, I'm Eby Isaac, an AIT PM. My job is to apply AI ML in telecom domain to get meaningful insights and use those insights for automation, optimization, or a meaningful change. So that's a quick intro of me. The session objectives is to one, you'd understand the AI use case flow. So anything that you solve, a problem that you'd be solving, would be considered to be a use case. And there's a flow of use case right from problem definition and all the way up to production and maintenance. And you'll be seeing that in the next slide. Then you go ahead with model performance and how do you gauge that the model that you deploy would be good. By model, I mean an AI ML model. Then the environment and where your model and your use case is going to be deployed, and pipelines that are involved, both ML and data pipelines, security and reliability, and the issues and challenges that you'll be encountering, and share you some of my experiences too in this regard. And throughout the entire session, I would prefer to be interactive. So if you have any questions, you can fire away, and Dr. Doreen would be pinging me. Okay, I hope that's fine. So moving ahead, the starting would be problem identification. Now, this itself is a problem in itself, to identify what problem to solve. And after identifying what problem you'll be solving, you're moving towards your proof of concept. So you've identified a solution for your problem, and you want to try out the solution and see if it really works. And once it works, you would have the proof of concept, or a POC, at your hand. And most of you would be already familiar with this. So in your undergraduation, you'd be expected to have an open problem, and there'll be a research paper that might have been already published, and you would see how it can be even better and solve that problem in your own way and provide a better proof of concepts than that is already published in that paper. And PhD or postdoc, that's when you go for both problem identification and proof of concept. So you try to spend most of your time just identifying what problem you want to solve, and then you generate a proof of concept and how to make it better and get the work done. But when you go for industrialization, you would start up with the problem identification, and then you get a proof of concept, show that this solution works in controlled environment where you'd have the data set, you have the testing output. Then you go for first office application. This is a part of development where you would have your product ready to be tested in a customer environment. So in vague terms, it's more of a beta testing. So you would have alpha testing done in between proof of concept and first office application, where you test whether all the test cases, all the functionality of your product works as desired. Then you would give it to the customer and see along with your connection. So you would still have your support to the application, your direct connection to the application, and the customer would also have control to that application. This is what we call the first office application. And once the customer is happy with whatever you deploy, you would accept as it is, which is mostly not the case. You would get some feedback on what to change, and then you go back to the proof of concept stage where you generate any additional features and get back to the first office application. And once the customer is happy with all the deployment, and once your test cases are satisfied, it's not just for the customer, you're also testing for your own product benefit to check if your product works in another uncontrolled environment. And once that's okay, you go with production. This is when you know that the customer will be able to use the product without your supervision. And once that production deployment is complete, you go for the maintenance phase. So if there's anything up with the product, any updates, you'd make periodic updates. But this is the life cycle of a use case. So let's get to the age-old question. Which is the best machine learning model for a given problem? A machine learning model comes with variable algorithms, a variety of algorithms, and every algorithm for a given class of problem. Let's say for classification, we have random forest, neural networks, deep neural networks, support vector classifiers, linear support vector classifiers, so many Bayesian methods too. And all of them will take a data set which has a set of features, and you map those attributes to a label. This is for classification. And what would you say to be the best? Something that comes to your mind might be the model that most correctly predicts what is expected to predict, right? So in loose terms, it's accuracy. But we have many other things in machine learning we call precision, recall, F1 score, etc. Or to go beyond, you can say area under the ROC curve, receiver operating characteristics curve, or R squared in terms of regression. And these are all metrics. It, either ways, you want to minimize the error to maximize is whatever you want to predict as accurate as possible. Or is it? And this is why I'd like to introduce to a quote. Knowledge is knowing the tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. Just because something is good seemingly on the outside, it does not mean it'll solve your purpose. So the model with the least prediction error is not always the most suitable model for a given problem. So this is when the stuff you learned in your earlier years of undergrad comes back to haunt you in your solution. Data structures and algorithms. I will not go too much into details on that, but I'll show you about what constitutes actual model performance. Everything that we discussed so far in the past 2 slides covers evaluation metrics. So this is where we look at the comparison of what is expected and what you receive, and the difference between the expect and receive in various computation like a F1 score or accuracy would determine how well your model performs. Another dimension to look at it is computational complexity. So this is where you have to look at 2 dimensions in computational complexity. This is for space and time, how much memory that you utilize and how long does it take you to compute. A good example of this would be deep learning. Now deep learning has become so famous, they want to retrofit deep learning in almost every use case possible. You tend to see papers that applies deep learning to even the most simplest of tasks. So imagine this scenario where you would have to find or predict whether anomalies are occurring in a certain cell, or let's say predict a variable of a KPI. KPIs keep forming index, and a cell or a cell tower would have many of such KPIs, and you'd want to predict the value so that you can prevent the failure. Now, prediction can be done with many algorithms, these forecasting algorithms, and you could even go for deep learning algorithms. And deep learning algorithms would require a significant amount of resources. Now, imagine this: these cell towers already fitted with computing elements, and they're there to do a certain task. On top of this, you want to include some AI ML algorithm so that you can do an additional use case on top of the existing resources. Now, if you'd want to put a deep learning algorithm in there, that means you would have to fit something like a GPU or additional compute VMs and try to even for a lightweight deep learning model. Now, imagine doing this for an entire region. Now, if you fit a GPU in one region, and I mean, in one cell, in an entire region, you can go close to 50 to 70,000 cells in a single region. That is expensive. And in general, when you go for business, you do something to either minimize a cost or make a profit. And this is not going to help in any way. This is not be helpful to the business. So you'd have to go for the simple algorithm, even if it is 10 or 20% less performing than the deep learning algorithm. As long as it's good enough, it give benefits for the business. You would not need to spend extra resources for the same. Then interpretability and explainability. And I would like to again bring the deep learning and neural networks into this algorithm. Into this comparison. Suppose you'd want to compare how 2 models are performing, and you go for face recognition. When I give a machine learning algorithm, it shows my face and it finds my name as such. It writes Ebi next to my face. Then it's good. It's understood that I am Ebi. And you don't need to know in detail about what is it doing to identify that I'm Ebi. As long as it knows that I'm Ebi, it's done. But suppose if you're going through, again, the cell tower scenario where you have over 500 KPIs, these 500 variables, and you're trying to identify whether an anomaly has occurred in the system or not. So an anomaly is an unforeseen occurrence that is rarely occurring in the system. Okay, unexpected occurrence. And if a system, suppose if you build this machine learning model, let's say in neural networks, and you feed in this 500 variables, and then the output is just yes or no. Yes for anomalous, no for not anomalous. What do you make out of it? What would you expect the operator to do? So generally, you'd want to identify anomalies to solve a problem, to know what has gone wrong with the system. But if the output is just it is anomalous, or is not anomalous, is not going to be much useful for you. And that is why you would want your models to be interpretable where it needs to be. So if you can readily verify the output of a program, for example, face generation or object detection, you can verify that output visually. It's okay to use complicated models where it's not that much interpretable or explainable. But when you are searching for patterns between the data and you'd want to visualize or understand those patterns, you would have to ensure that your models are interpretable and explainable. That's why you'd have to go simpler models like decision trees to do the job. So when you're going to apply your application in deployment, when you're designing a model for your machine, for your problem, make sure you consider these three dimensions: evaluation metrics, computational complexity, and interpretability. Then we move on to the environment. So this is where your uh, program runs. So environment consists of resources, and there's two specific resources. There's a compute resource and a storage resource. And this is important because when you run a program, usually you would run it in your laptop or you run it in a virtual machine outside. And you would need to know how much resources are you taking into consideration, because this is be very much important for hardware dimensioning. When you're deploying your solution and in any venue, whether it's a customer venue or even if it's going to be in someone's phone, you should know how much resources you're using, how much uh, capacity will be required, how much thread this uses, how much CPUs would be required to run the application, and how much memory would be required, or how much storage memory, secondary memory, and how much main memory will be required. All those things have to be taken into consideration. Then we have network connectivity. When installing an application, so generally when you install something in Python, you just do pip install that package. That's it, right? And you would expect that when you want to install this Python programming, the output of your project would be a Python file. And if you want to expect that Python file to work in the customer environment, you have to make sure that all the packages and dependencies in that file is covered in your customer environment or your deployment environment. And not all environments have internet connectivity. They have firewalls and they have certain ports that need to be open so that you can communicate between components. And internet availability itself is a question. The reason being, the internet is operated so that the nodes within each other can communicate. And they would have voluntarily blocked the internet away from those nodes so that the entire environment will be safe. This is what we call an air gap. And we have air gapped installation methods so that you take packages separately and you have to have all those packages brought into the customer environment through file sharing. Then you'd have to install it. So these are all complications that you'd see when you actually deploy the model, but you should be wary of it. So the best thing to do is to avoid the dependency of packages. But if at times where you cannot avoid, you would have to have those packages separately taken into consideration. Then we move on to pipelines. So those who are familiar with machine learning would already understand what a machine learning pipeline is. It starts with pre-processing, where you take the raw data from the data set and process it in a way that will be suitable for your training model, your machine learning model or algorithm. And then you proceed with training. You take the pre-processed data set and you push it to training, where we have so generally in machine learning, you'd have records, and every record would have labeled uh, instances. So the input would be the set of features of a record, and the output would be what you're expecting. And this is for a supervised model. For unsupervised model, you try to find patterns in between. So after pre-processing, you proceed through training, where your model understands the pattern of the data. Then you are ready for inferencing. Once your model understands the pattern for data, for every new incoming data, you can pass that model through the same pre-processing step and then identify a whatever that model is supposed to be. So and then we go for post processing, so that whatever model whatever output comes from inference is understandable to that application concerned. So and an example of this would be, again, let's get into the face application. So given a bunch of faces you would want to identify, let's say you want to build a system to for biometric facial identification. So your pre-processing would be your data set would be a bunch of faces and names. And the pre-processing would be to take those faces and extract the features that would be required, right, for your training model to identify. Then your training model can be any machine learning model, let's just say for simply neural networks or deep neural networks. And it'll take in those features and tag it to a label. The label would be your name. So next to my face, it'll be my name. And next to, let's say, Dr. Doreen's face, it'll be her name. Okay? And these are labeling. And once the model is trained, it's ready for inferencing. So inferencing is, suppose you can put it in a hallway, and anytime it finds anybody else's face is coming on, it'll identify whether that particular person is understood or trained in that application. And if it identifies that person's face, it'll give that person's name. So that is the inference part. And post processing is usually machine learning methods would not come up with direct labels. It'll come up with only numbers. So if it's 100 faces, the identifiers would be 0 to 100. And then those 0 to 100 would be mapped into names. And this is a dictionary that you have to look up to. And then you do that post processing to know that this particular person belongs to, or this particular ID belongs to this particular name. So that's the ML pipeline. Then when you go for production, you would have to automate this pipeline. Surely when you run this in a Jupyter notebook, this is an application that you use to simulate, to run Python programs cell by cell. Data scientists use it a lot. You get to do all these things manually. But when you do it in production, you would not have control over this. And that's why you need workflow orchestration. So there's plenty of workflow orchestration options available, like MLflow, Apache Airflow, Argo Flow, and each one of them works slightly differently. And you'll know when you get to use them. I will not go these workflow orchestrators too much in detail. Let's move on to the data pipeline. The data pipeline proceeds with extraction. So this is where you extract the data that you'll be required for your application. Then ingestion. So you extract the data. The data can be extracted from multiple data sources, let's say from multiple nodes or multiple sensors. And all the data has to be ingested into your database. So ingestion is a process where you take the data that is extracted and take the relevant subset of the data that you'll be required for your application, and you store it for processing. So this is simply a database management system that handles the data and the intermediate data for the whole ML pipeline. So all the processes of the ML pipeline runs within this particular step of the data pipeline. Then we have a presentation layer. So everything that is outputted by the ML model has to be presented somewhere. So this is where you'd have dashboards, or you have forms, or anyway, or even web pages, somewhere that you can present your output in a way that can be understood or analyzed by the end user. A typical example in here through the Elastic Stack. So Elastic Stack is something that is more commonly used in here. And Beats is one way you can use to extract data. Beats is these lightweight agents that you can install in several computer nodes. And they would periodically collect the data that is supposed to be programmed to collect and send it to a designated destination. And that destination can be a program that is fitted with Logstash. So Logstash would collect these multiple data sources, as in, for example, sent by Beats, and send it to a designated location along with certain filtering operations. So Logstash does the filtering and send it to Elasticsearch. The Elasticsearch in here is the database. In the simplest terms, the database management system. This is where all the intermediate data and the process data, pre-processed data, all of that is stored. And the presentation layer is Kibana. Kibana is a dashboarding system where is a dashboarding application where you can take in data from the Elasticsearch index and display it in multiple forms. So that's an overview of what an ML application looks like inside out. Now let's move on to an item that is mostly overlooked in the early stages. So I can go on for 2 days and still not complete the overview of the most critical elements of security and privacy required for a marketable product in today's world. But I'll try to cover the crux of what is required. Number one, security by design. Security should be considered in an end-to-end design and all phases of the software development lifecycle, SDLC. It's not an item in the checklist that you just tick off in the end. You'd have to consider this. Then limit 3PP. 3PP stands for third-party products and packages. And every time you include a 3PP, that means you're including a certain vulnerability in your device. Although they come for free. I mean, they can be free and they can be non-free. Suppose if you're looking at scikit-learn, Scikit-learn is a package that is most commonly used for machine learning applications. And we also have dashboarding tools like Plotly and so on. And all these are third-party packages. The reason why they're third-party because they're not built by your own team, because your team is considered to be the first party, and they're not developed by any other team in your company. That'll be second party. That's why they call third party. And the reason we have to minimize it is each of these packages come with their own vulnerabilities that you may not be able to see unless it starts affecting. And one common vulnerability, I mean, I could not brush away vulnerabilities without touching Log4j. Now, Log4j hit somewhere around November or December 2021, and that hit hard. This is a vulnerability that happens in, I mean, Log4j is a logging component in Java, but it is used in many applications around the world. This includes Apache Spark, and it also includes Elasticsearch, Logstash, and so many applications. And it crossed a global crisis, and this vulnerability would allow you hackers to get into the system. I would not want to share too much details in it. You can always see Log4j vulnerability, and it'll show common vulnerabilities and exposures, CVEs, that is tagged for Log4j. And even now, they're still trying to uncover new vulnerabilities because of it. Now, this vulnerability affected our system because we have a 3PP that is that we are depending on, and that 3PP depends on another 3PP, so on and so on. You'll have some cyclic dependency, so for, I mean, sequence of chain dependencies, and one of that is Log4j. This is just an example of what can happen if you have too many 3PPs. It's not, I can't say you can avoid 3PP entirely, but limit wherever possible. For instance, if you're using an algorithm from scikit-learn, it's good to do it for a proof of concept. But when you're going for production, it's best to code that algorithm on your own in a way that you don't need to use those packages. Then access control. Define all access of the system. Roles, for example, not just customer, seller, but also the operations and maintenance user. So you'd have to avoid that one user fits all problem. Usually people will not look at access control to a detail when they're going for proof of concepts, but you should identify what are all the actors in the system. Actors as in people who are users of the system. Each user would have its own role. Then logging. Logging for both security and general events. Logging can be a drag if you want to do the beginning. Logging is every time a certain application executes successfully, a certain feature runs successfully, or where something is unsuccessful, like a login failure or a network management failure. These are all certain events, and this will save you a lot of time in the future as well, even during the development, because if you're able to log all these important activities, you should be able to circumvent any other problems in the future. Then traffic and data protection. This goes without saying, because any application that you'll be installing, right now nearly all applications would be installed in a certain network or network infrastructure. You would expect data to come to and fro the application via a network. So you would make sure that the data that is passing through the network would be protected, and the data that is stored in the infrastructure. So when you're storing the data in your hard disk or wherever possible, that data should be also protected. Then we have OWASP Top 10. The OWASP stands for Open Web Application Security Project, and it's listed as the most critical security risks to web applications. Now, when you want to launch something in a web application or a web app, you would have to look into these critical security risks so that you can minimize the risk wherever possible when you're deploying that application. Then right to privacy. And of course, you would have heard a whole lot of things just for the past 5 or 7 years. Companies like Facebook went through a whole lot of this problem because they overlooked this. And a good example would be General Data Protection Regulation, the GDPR. And whenever you have your application that is facing publicly, you would have to show what are all the information that is being used by your application that is provided by the customer. So anything that is generated by the user and something that you're using, you would have to have their consent. Something like looking at browser cookies, storing the click-through rates, aid scrolling, any other data that will be useful for your application. It is generated by the customer. So the customer have the right to privacy, and you'd have to show that you're using it. Now let's go to some issues and challenges that you face when you're going with AI industrialization. So we have a few technical issues and some non-technical issues. So let's go with the technical issues first. So we have use case centric model performance. You're not selecting a model for a broad machine learning problem. It is for a use case. So whenever you select a model, do not think, okay, we're looking at anomaly detection. Let's just check the best anomaly detection available in there. Identify your constraints, what environment you're going to run in, and how much compute resource that you can afford, how much is going to cost you, and how much cost you're going to save by giving this much amount of accuracy away. Identify your trade-offs. And this is, and also stability of environment and system. When we were first developing an application, we identified we're going to use Kubernetes. Okay, Kubernetes is a container orchestration system. So I don't need to give you too much of the details of that. That's out of the scope of this presentation. But the problem is that particular system was running very well in our test environment. And when we deployed it into the customer environment, it started going some problems. But the customer environment has all other applications running perfectly fine from them. And then we realized that uh, there is a known issue between Kubernetes and NFS, network file system. And you would have to do some version changings for that. So just because an application runs well in your test environment does not mean it is always expected to run well in the customer environment. There could be always something that you'll be overlooking, and you'll only know when you test it. And avoid one user to rule it all. So this comes into the access control part. People generally use one user all the time, and that one user, one monolithic user, does everything. So you can, that one user can go for all the security functions and even the base end user functions. So you should segregate what are all the roles that are required, and know that this user is used for access control. This is a system administrator. It should only be used for administrative purposes. And this other user, be end user, you can only use to access the application for what is required. He cannot access any other system administrative purposes. Time sync across all your nodes. This is a funny thing that we've noticed in one of our deployments. And when we're troubleshooting, we found that during ingestion, we have the date as a certain time, and we were missing some data. And we find that the data is hits the system. So data is ingested into the system, let's say around 9 o'clock. Uh, the creation date is 5 hours later, like 1 p.m. So the data came in at 9 in the morning into the database, but the data is created at 1 p.m. And this is because there was this time sync problem that happened from between 3 to 7 hours between all the systems. So we have a network of systems running these applications where the data is created and the data is ingested, and we find that the time is not in sync. Okay? So each one has its own time. So this is where you would have to reinitiate the NTP. NTP stands for Network Time Protocol, and we'd have to restart that so that all the nodes are in time sync. Staging and production environment. So this covers what I stated earlier regarding the environments and the stability. Whatever happens in staging environments cannot be always expected to run in your production environment. You should try to make this gap between the staging and your production environment as small as possible. So this is when you would have to ensure that your staging environment is running the same OS, the same resources, the same memory, everything that your production environment is. So that's why we call it a staging environment. That's a place where you do your testing so that it works before. The staging environment is like the last step before it hits the production, and you would have to make it as similar to production as possible. And high availability and disaster recovery. Once your application is deployed, it's not over there. There may be some issues where certain nodes can fail. If your deploying your application in multiple nodes, certain nodes can fail. So if a certain node fails, you should not just stop the application altogether. There's a service level agreement that shows that if there's any critical application, there would be a service level agreement for that, so that even if some certain failure happens, you should have some fault tolerance in your system implemented. And disaster recovery is, even if the entire system shuts down, when it comes back again, and you should not be able to do your restart process. Your whole application should not be deemed useless. You should be able to come back from the fault and recover all the data that is lost, and start the business as usual with minimal business impact. So this is what high availability and disaster recovery is about. And these things have to be in proper handshake. You would have to confirm these things before you start the application. And this comes to the next issue, non-technical issues. SME availability. So SME stands for subject matter expertise. No matter how good you are with your application, from an ML standpoint, from a data science standpoint, you would still need a subject matter expertise to know whether whatever you're creating caters to the customers that you do. So this is where people who are domain experts in that area, they would know that you're solving the problem in a way that is supposed to be solved, and that'll be useful for them, the people who will be using the system. So they would have a better understanding of customers and end users than you do. And you should also value their time, because they're domain experts and users for a reason, because they'll be currently working in whatever they're doing, and they should be available for you whenever you need your feedback from them. Data center constraints. So sometimes not all the resources you ask would be available in a single data center. Sometimes they can be split into multiple data centers, and they may have a latency between them. And this is just one example, but there's so much more to this. And carefully set clear expectations. So all of a sudden, when you go ahead with your release, the customer should not come back and say that, no, we need a disaster recovery. Without a disaster recovery, you can't implement it. And then again, you have to go through a cycle. And then once you go through that cycle, when the customer says, no, we need to have this feature as well. So there would be some conflicting requirements, and requirements can change. It's not like just because you give a handshake at the beginning of the project, you should stick to that, because through this phase of delivery, you yourself might learn some things. So you would find that certain requirements are not really important, and certain may be more important. And the same goes with the customer, because their experiences change day to day. And once you have your business requirements set, it is not set in stone. But whenever the expectations change, you should have a proper discussion and negotiation to know that your timelines also change and your resources also change. So earlier you would think that with just 2 data scientists and 2 data engineers, you can finish the job. You would understand that, and even your customer would think the same. But afterwards, when you go deeper and deeper, you know that there's going to be a more complicated job. So this is not something that only 4 members can do. It requires a whole team of 50 members. And that's what happened in one of our examples too. And we would have to convey this to this. So earlier, it would not be taken lightly, because they would pay the amount for only these 4 members. They would have to pay again for the 50 more members, but you would have to make them understand what is their expectation. So carefully set clear expectations of what is your deliverables. And evolving requirements. So I just covered that now. So the requirements evolve as the project progresses, and that is unavoidable. It happens through almost every project. But you would have to understand that the project requirements evolve, and make necessary changes, and make periodic revisions to the plan. Also, be wary of intellectual property and licenses. So for people who are aware of machine learning and deep learning methods, I think you're aware of this method called the dropout method. And this dropout method, although you can it's freely available through your packages that you can readily install from TensorFlow, it is patented by Google. Likewise, you would find many of the methods that you use, even though they're freely available, are patented. And patent lawsuits can be expensive. Now, I'm not sure whether Google would really act upon the patent infringement, but it goes without saying, for other companies, they really will. And many companies make a lot of money out of it too, by suing others for infringing on their patents. So what you can do to save yourself from this IP and licenses. So whenever you're using any algorithm or using any package, look into the license and see what is their terms of usage. And you should be careful about what type of license you're using too. Suppose this famous license called GNU GPL v3. So this is called a virus license, where it is free. You can use that application for free, but when you're packaging and deploying it, you should make your code also visible, so that every package that uses this GNU GPL v3 license would also have to have the same GNU GPL v3 license. So these sort of GNU GPL license will be very good for research purposes and also doing your proof of concepts, but not so good when you're going for production level code, where you'd want to secure your code. So I think Apache license will be more better suited. And if in any case, you're using a known algorithm, make sure you have the permissions for that. And if there's any intellectual property associated with it, you would have to talk to that owner of the intellectual property, which is most probably another company. And if you feel that what you're doing is completely novel, make sure you patent it, because there's two chances. One, it is novel and it is patentable, and somebody else can copy it and then they can take the business off you. Or two, it is not novel and you're taking somebody else's business, so they'll sue you for that. So in any case, always make sure that whatever product you're doing it that is profitable, that is marketable, as long as you're getting some money out of it, it do some patenting over it. So if it's new, make sure you patent it. If it is not new, try to find out that whoever has the license for the same. So that comes us close to the end of our presentation. So let's review some concepts. So we looked into the use case flow and how the stages of the use case flow goes from problem identification, proof of concept, first office application, there's forward, production, and maintenance. Then we looked at the three dimensions of model performance: metrics, complexity, and interpretability. Then the environment in terms of resources and network. Then we looked at both ML and data pipelines. And security and reliability, we covered quite a lot of ground. The three more main things that you can take away from here would be security by design, limiting the 3PP usage, and privacy. And issues and challenges, we covered both technical and non-technical challenges. And that brings us to the end of the presentation. So if you have any questions, feel free to ask them.
Thank you. Thank you so much. All right. Thank you, Abhi, for giving a wonderful presentation on AI industrialization, right from the basics on ML algorithms and how you're putting onto your data pipeline, how it has been really used in the industry, the security, the staging, and the production use cases. Everything was clear, and I would like to ask the students, like, this is a part of your internship, and I would like to ask you to ask any questions. Feel free to unmute and ask. And there's one question on the YouTube live chat. All right, and the question is asked by Professor Gerard. He has asked, can you please explain the changes in the design of compilers to add machine learning?
Design of compilers. Now, I'm not aware whether they had to change any compiler design to add machine learning to it. Although there have been some researches that designs compilers through machine learning. That's another track on its own. So people are using machine learning algorithms to define more intelligent compilers, so that they can make coding more natural, just how a speech is doing. But as far as compilers are concerned, the job of a compiler is to convert language from one level to another level, or to one form to another form. So we have a Python compiler that changes the language from Python to C that happens under the hood. And we have Java compilers to convert Java languages to bytecode. But I'm not sure what the question exactly refers to regarding compilers and AI. But I hope what I said helps you in a way.
Thank you. Thank you. Yeah. And students, especially, we have like 133 students taking up their internship right from the basics of Python and progressively onto the machine learning. Girls, do you have any questions?
Yes,
Can you please? Yeah, yes, Ravi Ramya.
Yes. So, sir, you were talking about doing the issues. I'm not sure which one, but you did mention this syncing problem across the nodes, especially that happened with you. I think you've shared the experience where like there was like a time gap, and you did mention a little bit about how to tackle like something about NTP. Can you tell us a little bit more about that, please?
Okay, I would not cover the technical details of NTP, but NTP is what you use to sync across nodes. So you would have to install this application across all nodes. Although they should be readily available with Linux systems, and as long as those Linux systems are covered in a common network and NTP is configured for that network, you can instantiate NTP to give a sync. Details can be found on the Linux site on how to do it.
Okay, sir. Thank you.
Thank you, Ramya. Any other questions of people watching on YouTube Live? Also could ask and students. Yes, please. Any more questions? Yeah. And this is a part of the internship that they are doing it for currently at CIRF. We have two internships going on. One is on machine learning, and other is on data analytics, right? And it's on online, and it's always it is during the evening time, so that it is usable for the faculties and also for the students, right? And I would like to share that we are having our next internship that's going to be a 2 months internship on image processing. It is going to start from August 1st, right, between 7 to 8:30 on every Monday, Wednesday, and Friday, and it goes up to the end of September. It will be a 2 months internship on image processing, right? And anybody interested, you could join in for it. And currently now we have got these students going on from SDNB, right? They are doing on to their third day, right from the basics of Python. This is a 1 month internship. And the next internship that is currently we are going on is with the data analysis, right? This is on Tuesday, Thursday, and Saturday. The other one is on Monday, Wednesday, and Friday. So now the next opening would be for the 40 hours the internship on image processing using OpenCV, and also the other packages also will be dealt. It will be an hands-on session, and anybody interested, you could join to it, right? And other details you can connect to us, and we'll be able to do it. Right? Thank you so much. I would like any more questions. Still waiting for questions. We've got a few more minutes to go. We are all learning machine learning. What is your question? You could please ask. It's not an interview or anything. We have got a B who will be able to share this with us.
Not a question, ma'am, but I'd just like to express how grateful we are for Ebenezar sir for actually taking his time and telling us about how it works in the industry. We just appreciate it so much. Thank you.
Thank you. Appreciate that.
Thank you, Ravi. Ramya. Girls, you can ask questions. This is exclusively for you. They are very busy on their daily work at office, and inspired, they are here to share their expertise with you. You should have got an idea from the inception, from taking the data set, developing, and all the sectors like AB has covered towards it, so that you will have an overview of how it will be used in AI in the industry. There's a question on YouTube. Preferable language to work with AI other than Python? Asked by
Ah,
Professor Vijay.
that's a good question. Yeah, Python is currently is the most famous language and I'm working with fine, but it's not the most famous language. If you look at the Stack Overflow survey that has been recently released in 2022, you'd find that there's more alternatives. We have Swift, because Swift is what's Apple's using for their app development, and Swift is coming more and more famous, and you can use Swift for programming, and you can also go. I think Rust is also becoming more and more famous, although I'm not really that much well versed with. I mean, I have no exposure to Rust, but we have Swift, Rust, Golang, and Java. Java is still valid. You can still use Java for machine learning applications and even for graphical applications that to do with machine learning. It's still possible to use Java, and even many applications that that runs machine learning are still built with Java. For example, Elasticsearch, RapidMiner, or Weka tool.
Thank you.
Hope that
Thank you
answers your
so
question.
much. Yeah, that answers the question. And another question is asked by Griffin Graceful. How deep learning is different from machine learning?
Yep. Deep learning is an extension of neural networks. That's as simple as that. It's actually deep learning is machine learning, and it's not anything different from machine learning. Only that deep learning requires additional resources that general machine learning algorithms do not require. So when you have neural networks in just a couple of layers, when you can raise your number of layers to 9, or raise your 9 to or 10 layers, or have a number of nodes in a manageable amount like 100 or 300 or so. But when you want to raise the number of nodes to over thousands, but increase the number of layers beyond that, even if you give 3 or 4 layers, when you have over 1,000 layers, the number of parameters can go to millions. So basically you're counting how much parameters are being computed for your application. So if you're working with millions of parameters, then yeah, you're doing deep learning. And if your parameters are manageable, that you can even run in a normal system, you're doing basic machine learning. And there's even deep learning algorithm in Bayesian methods as well. They started using neural networks along with Bayesian methods. So you don't just do deep learning like what you do with combinational neural networks or resonance or so forth. There's so many ways to do deep learning, but basic understanding is that deep learning is not anything different from machine learning. It is machine learning, but it has some additional computations that are associated with it.
Thank you. Perfectly said. Because deep learning is a subset, right? And
Yeah.
thank you for that. And yeah, any other questions on YouTube and also girls? Feel free to ask any questions we have. Whether ML is possible without any past data? Professor Rajan.
It is. Well, although it's not exactly learning, but if you want to do without past data, you would have to find one way to code experiences into the algorithm itself. So either it learns from the data or it learns from the programmer who codes that machine learning program. So this is where we have this aspect called rote learning. So rote learning is when you're able to embed rules into the system, and you start with those rules, and the system can actually start with rote learned rules. So you can provide these rules into the algorithm, and you can learn rules through active learning afterwards. So active learning is when you already have a system that is well functioning and it learns from its mistakes. So this is a form of reinforcement learning. So reinforcement learning would not require data initially to start, but after starting it, for you to make sure that the system improves through experience, you would need data. So you'd have to improve system. You would have to improve on its own life cycle. Throughout its entire life, you'll be continuously learning to improve its target function. But if it doesn't learn from data, it's not really machine learning. It has to learn one way or another.
Rightly said, both machine learning and deep learning, we will be learning patterns from the data, right? And one last question from Divya. What are the common what are the common misunderstandings about AI?
Misunderstandings then?
Misunderstandings about AI.
Common misunderstanding in AI. Oh man, that's a very broad topic on itself. I'm sure many YouTube videos can know much better than I do right now. Since it's all of a sudden, they'll see that okay. I can tell you from the experiences that I faced. They feel that AI and machine learning, of course, they go hand in hand. AI and machine learning. Again, machine learning is a subset of AI, but with AI ML, people think they can solve any problem, which may be true, but not to a limit. So they think that okay, classification, anomaly detection, there's all sorts of problems with the all sorts of algorithms already there. Can you solve it? No, you can't just solve it by taking an algorithm putting the data and getting it through. There's always some validation you need to make. And a very good example of that, what I see, is anomaly detection. People think that anomaly detection is a solved problem, and they already lots of algorithms, lots of libraries there in the internet, and you can readily take it. But whether it be useful for that application or not, that's still questionable. Because with the same data set, that you can have multiple anomaly detection use cases. So the way a network operator would look at it will be different from a way that someone from the back office would look at it. The same data set I'm talking about, same KPI data and same work order data. And that's still anomaly detection. It differs from one perspective to another perspective. So to identify perspectives and how those perspectives can apply to the machine learning algorithm, you would need some level of human intelligence to tune that algorithm accordingly. So just because you use machine learning does not mean it makes your problems solved automatically. And right now, auto ML is something that is going along that dimension, but I don't feel that auto ML is there yet. So auto ML is where you have these you provide the maximization criteria. You provide which attribute you want to use to maximize, which attribute to, let's say you want to get the best accuracy or the best F1 score, best position, and you give a bunch of algorithms and you use the same data set, and the system would come back at you with an algorithm saying that this algorithm with this parameters would be the best for you. This is what auto ML is about in its base. But still, that is nowhere close to what closed loop automation is about. Closed loop automation is when you use any algorithm, not just machine learning algorithm, any algorithm, and solve the problem that causes that algorithm to provide a certain output. So let's say we work in anomaly detection. It says that this system is behaving anomalous and is giving this many fault values. This is an anomalously high. Okay, that's why. And just because it's high, we don't just leave it at that. You need to do some remedial methods to that system so that the anomalies don't occur. This is closed loop automation. So this itself would require another level of intelligence, which we're still not there yet. So you can't resolve all problems, but you can resolve to another problem step by step.
Thank you. And like one last question, can we ask?
Yeah.
Yeah. What is the difference between weak AI, general AI, and super AI?
I was hoping somebody will actually ask that question. So weak AI, general AI, and super AI. Okay. I think, of course, the answer should be already there. It's not something that the internet cannot answer. So weak AI is when we would have systems learning from the input data, and they learn from patterns. And general AI would be basically everything that we're doing right now is associated with weak AI, and general AI would be human level of close to human level intelligence, and super AI would be sometimes a set of intelligence that is equal to human level or even beyond human level intelligence. And I don't think we're in super AI yet. We're still struggling in the weak AI domain. And somewhere, I think some people also have realized general AI. So we have robots like Sophia. You must have seen Sophia. And there's also Sophia's little sister. These people, they made robots with the humanoid expressions. They can think like humans too. And there's also a recent, I think Lumin. Forgot. Google has its own artificial intelligence that came up. The Google engineers actually did whistleblowing on that, stating that it feels that it has its own sense of thought, that it has its own intentionality, that its own sense of thought. It is a real live being, and I'm not sure to which extent it is actually true, but yeah, general AI we're there. Super AI, I'm not sure we're quite there yet, but general AI we're pretty close.
Thank you so much, Dr. Ebenezar Isaac, for spending the time with us and sharing the knowledge on AI, on industrialization, from the inception till how the product is launched onto the industry, on different things, right, onto the securities, on the case studies, how it is to be done. It really gave an entire panoramic view of the entire system. And I hope, I trust, and it was very useful for everyone, especially for the students, right? When we were students, we didn't have an opportunity to get feel how we were learning some subjects, how it is being used in the industry. That is what at CIRF we want to give space the sense to the students. Like they sometimes they think, why do I learn, and what is the use of it? And when we bring people like you, and will be able to understand, and they're coming out of comfort zones and asking questions, and many professors also had been asking questions on to the YouTube live chat, and it has been so good to have you all here. And I'd also thank the students for their active participation, and also the professors wide over from different places. They have attended onto the YouTube live session, and it's really a good session. And thank you so much once again, Dr. Ebenezar Isaac. Thank you all.
Thank you, everyone.
And I want everybody to fill in the feedback forms, those who are into the YouTube live chat, and also those who are these students, the post-it within a week, you'll be getting your certificates. So thank you.
Yeah, and just a closing thought. Any theory that cannot be put in practice remains a story. So it's up to you to provide theories to practice. Bye.
Thank you.